everyone. Today we will discuss push-down automata for the context-free grammar. Context-free language, or also you can say context-free grammar. From the Chomsky hierarchy we got, if some language is there that is not accepted by the finite automata, then we will go for this language and push-down automata and check this. If it is not accepted by the push-down automata, then it will go to the Turing machine. So, which type of language this context free language is there, how it is accepted by the push down automata, and what are the tuples of the push down automata, we will discuss here. So, here push down automata, here what you have to do, push down automata, we need a stack data structure to store the input. Sometimes we require to store the input to compare with the next input. Suppose in your input here language, in your language see here in a language this finite this is a finite automata with stack memory, last in, you know the stack memory, this is last in first out. What you have to do, suppose we have a language L a to the power n b to the power n greater than equal to 1, then here a b will be compared. Then what you have to do, all you have to push into the stack, fit the all b, again you have to pop the b and make stack empty, then it will go to the final state. Then what are the tuples here? Here PDA having 7 tuples, this is capital Q, input alphabet state, and tau, this del, z, q0, f, and q is the finite set of states. This should be finite set number. Then sigma is the alphabet, input alphabet, and z is the stack bottom, and tau is the stack input alphabet, and this del is the transition function. Here we have to take one state input alphabet and stack input alphabet, go to the another state with stack top, and here you have given here input alphabet and also epsilon you can take input in tau, also in stack input sometimes you can take empty, like that. Then q0 belongs to q, and this is same thing with finite automata, and final state f is the final state which subset equal to accepted state which subset equal to q. So, what is the acceptance of PDA? PDA starts with an empty stack and it accepts the string if at least one of its computational branches read and all the input gets into an accept state and end of it. Means you have to read all the input and make stack empty, then PDA is accepted. You have to read all the input, then your stack is empty, then it is accepted. Also another way to PDA accepted, you have to read all the input and you are in final state, also it is accepted. Is two process we can accept the PDA, like the stack empty, another is you have to accept the you are in final state. So, in both cases you have to read all the input. So, here another language we have taken, that is a to the power n, b to the power n greater than equal to 1. This language here, what are the tuples? I told this is the 7 tuples. I will take one by one for this example. What are the tuples and how this is push, pop, like that, how no operation is there, we will explain in here. See here, suppose we will take a language L, L is a to the power n, b to the power n is greater than equal to 1. For this language we do not have the finite automata, because there is a comparison between a and b, then we have to go to the push down automata. This accepted by the push down automata. So, here is the, we have to design this one. Suppose q0 is the initial state, let me design, then after that I will explain. q0 a to z and this is az. A Z. You can like this Q0 A. You can like write this A Z, and this is A. Then for the B input, B A, and this is epsilon. Then this is Q1, then B A, this is epsilon, and here epsilon Z, this is Q final, Q accept state. So, what are here we have taken a language A to the power n, B to the power n, n greater than equal to 1, because there is a comparison from Chomsky hierarchy. We check already that this cannot be accepted by the finite automata. We have to go for the push down automata. So, here transition function you can say in your 7 tuples in PDA, here capital Q is Q0, Q1 and Q accept. Then another is Q accept, Q0, Q1 and Q accept. 3 states are there. This is Q accept. So, input alphabet is A, B, and this is tau stack input alphabet is, you can say this is A and Z. Z is the stack bottom, and here Z is the stack bottom. So, stack bottom, Z is the stack bottom, and you can say transition function, here transition function, then Q accept is the final state, Q accept is the final state, Q accept is QF is Q accept is the final state, and here is the tau, like then we have Q0 is the initial state, Q0 is the initial state, Q0 is the initial state. So, we have to go to the transition. What transition we are taking here? See here we are taking transition function, transition Q0 input alphabet A, stack is empty, then this is push operation Q0 AZ, and you can say this is a state and this is input and this is stack input, this is input alphabet and this is stack input alphabet, Then after that we have to go to another state, this is state and this is stack, So, this is the transition, function, you can say for each and every transition we have a state and input alphabet and also stack input alphabet, then go to the another state and here is the stack. So, here we have taken a language how this is accepted, this language is accepted by the push down automata. We will check now how this language is accepted by the push down automata. Let us take what are the transition here, you are writing this transition, we will write all the transition here. See here Q0 A Z, then go to the Q0 AZ, this is push operation, this is the push operation, this one is the push the stack. If Q0 state and A is the input and stack top is Z, then we have to push A into the stack. A push into the stack. This is push A into the stack, push A into the stack. Then after we have another transition, this is Q0 A and then go to Q0 A. So, what it is saying that if you have this is Q0 state, input is A, stack top is A, again A will be pushed into the stack, A will be pushed into the stack, this is push, again A will be pushed into the stack. So, another transition is there. So, if Q0 input B stack top is A, then this is Q1 epsilon. This means this A will be pop, whatever stacked up, this is the pop, this one is for pop transition, this is pop transition. So, this A will be popped, A will be popped and go to the state will be changed, going go to the Q1. Now, go to the Q1. Similarly, another transition is there, Q1, then input is B, stacked up is A, again go to Q1 and this is epsilon. This epsilon means here we have to pop each one symbol from the stack, this is Q1. Then next transition is there, Q1 epsilon and Z go to Q accept and this is Z Q accept. This means here if already you have read all the input and your stack is empty, your stack is empty, then it is accepted, go to the accepted say. So, this is the description of formal definition of push down automata, and I will explain how this language is accepted by this push down automata. We will take a string from this language, how it is accepted by the push down automata, we will go for that. And you see here I have written all the transition, this is the formal definition I am explaining, and here the state and input alphabet, this is the tau is the stack input alphabet and Z is the stack bottom, and here is the 5 transition is there, 5 transition is there, and initial state we have to A, Z, then A will be pushed. If A is input and stacked up is A in initial state, again A will be pushed into the stack. If initial state B input is there, stacked up A is there, then you have to pop A from the stack, and here also this A will be pop, from the stack, and if you already have read all the input, then it is accepted by the push down automata. So, this is the formal definition of the all the 7 tuples. It is the Q0 is the initial state, final state is Q accept, all the 7 tuples. So, we will go to how the string is accepted, by this diagram. We will check, we will take an example string from there, then I will check how this is accepted, check it. So, let me erase this. So, we will take a string, suppose we will take here triple A, triple B as a string, how this string is accepted. So, here we have to take the language generated by triple A, triple B. Let us take triple A, triple B, which is generated by this language A. When n equal to 3, this is triple A, triple B. So, how this is accepted? So, here we have to take Q0, then input is A, A, B, B, and this is stack is Z. Stack is Z. This is the Q0, input is A, B, B, and stack is Z. Now see what is the first transition. What you have to do, first transition is your input A and stack top is Z. Stack top is Z. Input A and stack top is Z and state is Q0. So what you have to do, A will be pushed into the stack. You see here, if in Q0 input A and stack top is Z, then what you have to do? Then A will be pushed into the stack. You can say this is the input, this is input and this is stack. Input and here stack. So here input Q0, input A, stack top, then what you have to do? Q0, A, B, 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 then A, Z. So this is the first transition we took here. Then Q0, stack input is A, stack top is Z. Now you check your state is Q0, state is Q0, input is A and stack top is A. Then again it will be go to Q0, A will be pushed into the stack. So here Q0, then A, B, B, then A, Z. So now your input is A, stack top is A. Again same it will be go to loop. In Q0 input is A, stack top is A. Then what you have to do? This is Q0, B, 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 A, Z. A, Z. This is Q0, B, B, A, Z. Then after you see here, input is B, stack top is A. You are in Q0 state, input is B, stack top is A. Then what you have to do? We have to pop. We have to pop this A from the stack. For each and every B, we have to pop one B from the stack. You have to pop one B from the stack. So here it will go to the Q1 state, then B, B, this is A, Z. So we pop one A from the stack. We change the state Q0 to Q1. Q0 is the state. This is Q0 state. Q0 state, input B and stack top is A. So we pop A from the stack. Then after again Q1 and this is, see here, input B, stack top is A. Again it will go to Q1 and pop A from the stack, pop A from the stack. So this is B and this is A, Z, A, Z, A, Z. Then after you see here Q1 B, A, Z. Then after again we are in Q1 state, then input is B, stack top is A. Again you have to pop another A from the stack, another A from the stack, and this is empty and this is Z. Now you see in Q1 epsilon Z, then you have to go to the Q accept state, Q accept states. So this is Q accept, then the string is accepted by the diagram. So here equal number of A, first you have to read all the A and store in the stack, push into the stack. Then after each and every B, we have to pop each A. For each B, we have to pop one A. Then after that make stack is empty and read all the input and go to the accepted state. So this is the accepted. You can say here we are using push operation. Here we are using push. Also this is push. This is push. Then here pop operation. Then here pop operation. then here pop, then this is no operation, no operation, no operation. No operation means just read the input. No operation means you just read the no operation. Read the input and no need to operation in stack, no need to any operation in the stack. So this is the no operation. If no operations, I can say, suppose another example of no operation like that. Suppose you have a transition like that. Suppose Q0 A, and here is the B, and this is B, and this is Q1, this is Q0, and this is Q1. You can say this is the no operation. This is the no operation. No operation. This is the no operation. Means we read here Q0. In Q0 state, we read here A, then whatever stacked up B, that was remain same, after going to Q1, then no operation. So here is the last step. We are not doing any operation in Q1 epsilon Z. This is the no operation. So we can take any wrong string, how this is accepted. For this is accepted. The equal number of A and equal number of B is accepted by this language, and means this push down automata. All the string generated by the language that can be accepted by here, and this is a context free language. So here another example, I can say you take another string which is rejected by this diagram. So we will take a string here. Let us take a string. Let me take another string, how this is rejected. Suppose you will take here 2A 1B, 2A 1B, how this 2A 1B is rejected by this push down automata. How this 2A 1B will take a wrong string 2A 1B, 2A 1B. A 1B. So now start from the Q0. This is A, B, and this is Z. Then you can say here you have to push it Q0 A Z. Then what you have to do? A B, and this is A Z. Push. You have to push it. Then Q0 A. Then again Q0 state input is A, stacked up is A. Again you have to push it B, and this is A Z. This is input, and this is stack. Input, and this is stack. Now again Q0 B, what you have to do? Q0 B, then Q1 epsilon A Z. You pop 1A from the stack. Q1 you pop each B, see Q0 B, when B and stacked up A is there, we have to pop this A, pop A. Pop. Then what you have to do here? Q1 epsilon A Z. So there is no transition from Q1. Epsilon is you have epsilon input alphabet, and stacked up is A. Stacked up is A. So that's why it is rejected. No transition. No transition. Then rejected. So this is the push down automata. I gave one example, that is I explain all the tuples, then how to design push down automata using stack, and also I check it how string is accepted, and take a right string how this is accepted and a wrong string how it is rejected. So in next in next class we will go to the deterministic push down automata and non-deterministic push down automata. For some language there is a deterministic push down automata and some language there is a non-deterministic push down automata. For next lecture we will go through this, and these are references. Thank you.